So we have a bunch of trigonometric identities, right? So the identities that we have so far are, we have the reciprocal identities. Maybe I could try to write a little bit neater here. We have the reciprocal identities. This would be like sine is 1 over cosecant, cosecant is 1 over sine, right? And so on. We have the quotient identities. Right, this is like tangent is equal to sine over cosine, cotangent is equal to cosine over sine. All right, we have the Pythagorean identities. Right, so this is like sine squared of theta plus cosine squared of theta is equal to 1 for all theta, right? And then the two equivalent forms for that, right? We have even and odd properties, which are technically other identities, okay? This would be like sine of negative theta is the same thing as negative sine of theta, but cosine of negative theta is the same thing as cosine of theta, right? We have cofunction identities. Okay, so we have a bunch of identities that we went over in various sections. Now, today we're going to be talking about some lesser known identities, right? Things that aren't very common, and we're going to try to prove that they're true, basically. So, for example, right, let's verify the following. Let's verify that sine of x divided by 1 plus cosine of x plus 1 plus cosine of x divided by sine of x. That this is actually going to be equal to 2 cosecant of x. Okay. So we're going to verify that this is true. So what we're going to do is we're going to start with the side that looks more complicated. Right? I have a lot of division over here, and then I'm adding these two fractions together, so that looks more complicated. And our goal here is to take this and then through a series of algebra steps and trigonometric identities, right, simplify this so that it looks like the other side of the equation, like 2 cosecant of x. Okay, so I'm going to start off this way. I'm going to just start off just writing this down. Sine of x over 1 plus cosine of x plus 1 plus cosine of x over sine of x. Okay, and then I'm just going to say what that's equal to, right? Now, I don't see any trigonometric identities I can really use just yet. So I'm going to use algebra instead. I have two fractions, right? So I have two separate terms here, right? I'll go ahead and circle them, although I think it's pretty obvious. There's two terms right there. But my final answer is supposed to be just one term, right? So let's see if I can combine these fractions together by getting a common denominator then. Okay, so that's what I'm going to do here. So getting a common denominator, right, means that my denominator should be sine of x times 1 plus cosine of x, okay, for both of my fractions here. Okay. Okay, so that would be our common denominator for both fractions. So in my first fraction, right, I have a sine of x upstairs already, right? And I have I have a 1 plus cosine of x upstairs, downstairs already, right, in the denominator. So then I need to multiply by sine of x in order to get sine of x times 1 plus cosine x in the denominator, which means I also need to multiply my numerator by sine of x. So I get sine squared of x upstairs. Okay, so I multiply the numerator and the denominator by sine of x in order to get that common denominator. Okay. For my next fraction, right, I have a sine of x downstairs, so I need to multiply my numerator and my denominator by 1 plus cosine of x in order to get that upstairs, okay? Oh, sorry, in order to get a common denominator, I should say. Okay, so I'm going to have a 1 plus cosine of x quantity squared then. All right, so then now we're going to simplify this as much as possible, right? We have a common denominator, so we can write it over a single fraction. We have sine of x times 1 plus cosine of x. You might be tempted to distribute this. I advise you to actually leave it factored. It's probably better that way. You'll probably get more cancellation, okay? So that may not always be the case. We may see an example later where it's better to go ahead and distribute it. But for right now, let's just leave it factored. So I have a sine squared of x, and then I'm adding to that 1 plus cosine of x quantity squared. So when I FOIL that out, right, I'm going to get a cosine squared of x plus a 2 cosine of x plus 1. Okay, so this is all algebra so far. Okay, all of this is just algebra. Now, I have a sine squared of x here, and I'm adding to that cosine squared of x. So now's the part where I'm going to use a trigonometric identity. And maybe I'll actually write this off to the side over here, right? Pythagorean identity. Pythagorean identity. Oh, you know what? I should probably put that in the next step because I haven't actually used it yet. I'm going to use the fact that sine squared of x plus cosine squared of x is equal to 1. So this is going to be the same thing as, well, sine squared of x plus cosine squared of x just combines to give us 1. And then we have plus 2 cosine of x plus 1, all divided by sine of x times 1 plus cosine of x. Okay, so there, right, I have used my Pythagorean identity. Pythag identity. There we go. Okay, so that's the first trigonometric identity I actually used there. Now, we do a little bit more algebra cleaning this up. So I have a 1 plus 1, which is, of course, 2 plus 2 cosine of x, all divided by sine of x times 1 plus cosine of x. Okay. Now I'm going to factor the numerator, right? The denominator is already factored. If I factor the numerator, I can actually pull a 2 out of both those terms. I'm left with a 1 plus cosine of x. Downstairs, I still have my sine of x times 1 plus cosine of x. And now I see I have a common factor in the numerator and the denominator. That's going to cancel off. And so this is really just 2 divided by sine of x here, right? Again, this is all algebra so far. But now, right, 1 over sine of x is the same thing as cosecant of x. So this would be the same thing as just 2 cosecant of x, where I've used my reciprocal identity. Right, that 1 over sine of x is the same thing as cosecant of x. And so that's what I mean by, through a series of algebra steps and trigonometric identities, we were able to show, we were able to verify this identity, that the left-hand side is indeed equal to the right-hand side. Okay. Okay, so let's do another example of that. Okay, let's do another example. Let's verify this identity. What if we have 1 over 1 minus cosine of x plus 1 over 1 plus cosine of x? And we're going to verify that that's actually equal to 2 cosecant squared of x. Okay, so let's try that out. Again, I'm going to start with a more complicated side here, right, which to me looks like the left-hand side. So I'm going to have a 1 over 1 minus cosine of x plus a 1 over 1 plus cosine of x. And you might notice a little theme here that when you have fractions and you're adding them together, it's good to get a common denominator as a first step there, right? You know, do algebra first, basically, right? So I'm going to get a common denominator, right? So my common denominator is going to be 1 minus cosine of x times 1 plus cosine of x. Okay. So then that's going to be my first fraction, and my second fraction is going to also have a 1 minus cosine of x times a 1 plus cosine of x. Okay. In my first fraction, I would need to multiply by 1 plus cosine of x on the top and the bottom. Okay. And in my second fraction, I need to multiply by 1 minus cosine of x on the top and the bottom to get that common denominator. Okay. But now that I have that common denominator, let's go ahead and see what I get here. So my downstairs is 1 minus cosine of x times 1 plus cosine of x. Okay. And then now I add my numerators together. So it's 1 plus cosine of x plus 1 minus cosine of x. And as you can see, I'm going to get a little bit of cancellation. My cosines of x just cancel off there. So then upstairs, I just have 2, right? And this is all divided by 1 minus cosine of x times 1 plus cosine of x. Okay. And keep in mind here, I haven't used any trigonometric identities yet, right? So far, all I've done is just use algebra to get this far. Okay. So now, right? Well, you might say, well, now I don't know what to do next. Okay. And in my previous example, I said it's probably better to leave that denominator factored out because you'll get better cancellation that way. But as you can clearly see, I have my numerator completely factored, my denominator completely factored, and nothing is canceling off, right? So in that case, maybe we should try and FOIL out the denominator and see what happens, right? So we FOIL it out, we get 1 times 1 is 1, plus a cosine of x minus cosine of x cancels off. So then we get minus cosine squared of x. Right? So 2 over 1 minus cosine squared of x. Okay. And then now, right, I'm going to mark this as a Pythagorean identity, but I'll put a little aside over here first, right? Show a little bit of work here. We know that sine squared of x plus cosine squared of x is equal to 1. Okay. But if we subtract cosine squared on both sides, then this is equivalent to saying that sine squared of x is equal to 1 minus cosine squared of x. So downstairs over there, this is going to be 2 over sine squared of x. Okay. Now, I'm going to make a note here that I used my Pythagorean identity to get that. Pythagorean identity. Okay. So 1 minus cosine squared is just the same thing as sine squared of x. But then now this is the same thing as 2 cosecant squared of x by using my reciprocal identity. Okay. And so again, we have shown that the left-hand side is equal to the right-hand side. Okay. I'm going to do one more problem on this. Okay. So let's suppose we have something like this. Verify. And now we're going to say secant of x times tangent of x minus secant squared of x is equal to negative 1 over 1 plus sine of x. Okay. So then now we want to kind of approach this the same way. We want to take the more complicated side and show that it's equal to the less complicated side. Okay. And you might look at this for a second and say, well, which one of these is the more complicated side? Because on the left-hand side, I have secants and tangents and secant squareds, right? Yeah, so that's complicated. But on the right-hand side, I have this fraction with a 1 plus sine of x in the denominator, right? So which one is more complicated? I think the left-hand side is more complicated because secants and tangents are harder to work with, basically. So I'm going to start with the harder side, which is the left-hand side. So I have secant of x times tangent of x minus secant squared of x. Okay. And you might wonder now, like, okay, well, how do I start this problem, right? I don't see any algebra steps I can really take here. I mean, I guess I could factor out a secant of x if I wanted to. But I think whenever we have secants and tangents running around, and you're not sure how to start the problem, I think a good first step would be to convert everything into be cosines and sines. Okay. So so secant of x is the same thing as 1 over cosine of x, for example, right? Okay. And then tangent of x is the same thing as sine of x over cosine of x. Okay. All right. And then secant squared of x, that's the same thing as 1 over cosine squared of x. Right? So there, what identities did I use? Well, I used a reciprocal identity for secant, right? And I used the quotient identity for tangent there. Okay. Fair enough. So those are the two identities that I used to get there. All right, now I'm just going to kind of clean this up a little bit. So I have a fraction times a fraction. So I have sine of x over cosine squared of x. Okay, and then I have minus a 1 over cosine squared of x. All right, so now I have a common denominator. So this is the same thing as sine of x minus 1 over cosine squared of x. Okay. All right. So now looking at this, right? Now, where do I go from here, right? So I have sine of x minus 1 over cosine squared of x, right? And nothing's really canceling off, right? It doesn't really look like the right-hand side of the equation yet, okay? So what can I do? Well, I have a cosine squared of x in the denominator, right? So maybe I can use my Pythagorean identity again, right? So just as a reminder here, right? We have that sine squared of x plus cosine squared of x is equal to 1, right? And so that sine squared is the same thing as 1 minus cosine squared of x by subtracting cosine squared on both sides, right? But we also could have subtracted sine squared on both sides, and we would have gotten that cosine squared of x is equal to 1 minus sine squared of x, okay? So then My Pythagorean identity gives me that my denominator here is really the same thing as 1 minus sine squared of x. Okay? So I have a sine of x minus 1 in my numerator divided by a 1 minus sine squared of x. So that's my Pythagorean identity. Okay, at work there. Okay. So again, I still have nothing that will cancel off, right? Because I need to be able to factor the numerator, factor the denominator as much as possible, and then I can cancel off common factors. So, well, my numerator is completely factored already. My denominator, right? Well, that does actually factor pretty nicely. It factors as 1 minus sine of x times 1 plus sine of x. Okay? Right, you might remember from college algebra the difference of squares formula, right? So, right, I just use something called the difference of squares. Okay. And so you might look that up if you have trouble factoring that. Okay. It basically says this, though. If we have a squared minus b squared, that's always going to be a minus b times a plus b. Okay. All right. So now we're almost in a place where we can cancel things off. I see I have a 1 minus sine of x in the denominator here, which is great. Okay. And I see I have a sine of x minus 1 in the numerator, right? So if I factor a negative 1 out of the numerator, then I'll be left with 1 minus sine of x. Okay. And now I see some cancellation. I have a common factor here and here, which are going to cancel off. So then this is going to be a negative 1 divided by 1 plus sine of x. Okay. And there we have it. Okay.